Have you ever watched a Formula One car blast through a corner at, over 200 miles an hour and just wondered, how in the world does it stay on the track? It's not just the tires. It's an invisible force, a powerful river of air that engineers sculpt and bend to glue that car to the ground. Today, we're diving into the amazing physics that make these cars fly, but on the ground.
So here's a wild thought for you. A Formula One car is basically an airplane that's been flipped upside down. It sounds completely backwards, right? A plane wants to go up and an F1 car wants to do the exact opposite. But believe it or not, the secret to their insane cornering speeds is all about mastering the same physics of flight, just turned on its head. And this is the key to everything, downforce. It's really just negative lift. You see, an airplane's wing is curved on top. Air has to travel faster over that curve, which creates low pressure and pulls the plane up. F1 wings do the exact opposite. They're shaped like an upside-down wing, forcing air to speed up underneath them. This creates a massive low-pressure zone that literally sucks the entire car down onto the tarmac. In fact, get this, at around 150 miles an hour, an F1 car makes so much downforce, it could, in theory, drive upside down on the ceiling of a tunnel. Wild. Okay, so let's break it down. You've got four main forces working on the car. There's thrust, from that incredible engine pushing it forward. You've got weight, just gravity pulling it down. But the real aerodynamic fight is between drag, that's the air resistance trying to hold it back, and what this diagram calls lift. For an F1 car, we just flip that arrow and call it downforce, and that is the absolute star of the show. This right here is the fundamental trade-off. It's the constant puzzle that keeps F1 engineers up at night. You want all the downforce you can get to absolutely fly through the corners, but creating that downforce almost always creates drag, which is like having a parachute open on the straights. The perfect F1 car is a master of this balancing act. So how do they actually create all this downforce while keeping drag in check? Well, it really comes down to two main parts of the car. The obvious ones, the wings, and the not-so-obvious one, the incredibly powerful underbody. Now check out this breakdown. The front and rear wings are absolute powerhouses, right? Each one is responsible for about 25% of the car's total downforce. That is a ton of grip. But, and this is a huge but, look at the trade-off. Together, they also create a whopping 50% of the car's total drag. So yeah, they're powerful, but they're aerodynamically very, very expensive. Now, the under tray, or the floor of the car. This is where the real magic happens. It's just a marvel of efficiency. For the same little bit of drag, it produces way, way more downforce than the wings. This is kind of the holy grail of F1 aero, and it's all thanks to something called ground effect. So how does that work? Well, think about putting your thumb over the end of a garden hose. The water speeds up, right? It's the same idea. The floor of the car is shaped into these big tunnels. As air gets squeezed through these narrow channels, it has to accelerate. And a basic rule of physics is that faster-moving air has lower pressure. This creates a powerful vacuum effect under the car, literally sucking it to the road. It's just brilliantly efficient. And you can really see this whole philosophy in action when you compare the 2021 and 2022 cars. The 2021 car is covered in all these crazy, complex little winglets and bits of bodywork, but the 2022 car, it looks much simpler and cleaner on top. And that's because all the heavy lifting is being done underneath the car in those massive tunnels. It was a complete rethink of how an F1 car should work. Of course, it's not just wings and floors. Literally every single surface on an F1 car is obsessed with managing airflow. Let's take a look at a couple of other key parts that shape how the car performs. Okay, so an F1 power unit creates a ridiculous amount of heat, and you need huge radiators to keep it cool. But if you just stuck those radiators out in the open air, the drag would be a disaster. The side pods are this really elegant solution. They're shaped to perfectly guide air into the radiators with as little drag as possible, and they even help direct that airflow to other important parts of the car. Now, before the 2022 rules, cars had these incredibly complicated parts called barge boards. Their main job was to deal with all the messy, turbulent, dirty air coming off the front wheels. They would catch that chaotic air, straighten it out, and guide it cleanly towards the floor and the side pods. They were amazingly complex, but they got banned to help clean up the air behind the cars, making it easier for them to race each other closely. And how do teams design all these intricate parts? Well, look at this. This is a beautiful image from a CFD simulation. That's computational fluid dynamics. It's basically a virtual wind tunnel running on a supercomputer. Engineers can see how every particle of air flows over, under, and through the car, letting them test thousands of ideas before they ever build a single physical part. It's incredible. So, why do F1 cars look so different now compared to, say, 10 or 20 years ago? It's because the designers are always innovating inside a rulebook that is also always changing. The sports governing body, the FIA, uses these regulations to manage things like speed, safety, and of course, how good the racing is.
This timeline really tells the story. You had the first wings back in the 60s, then the first ground effect era, which was actually banned because it got too dangerous. Then we had that era of all the crazy complex winglets, which got simplified, leading us to the return of ground effect in 2022. And next on the horizon for 2026 is another massive change: active aerodynamics.
For the last decade or so, a huge part of F1 has been the drag reduction system, or DRS. You know how it works. On certain parts of the track, if a driver is less than a second behind another car, they can open a flap on the rear wing. This kills a bunch of the drag and gives them a speed boost to try and make an overtake. But DRS is going away. For 2026, the sport is bringing in a way more advanced system that's going to completely change how drivers manage their car's aero performance lap after lap. This image shows you the future. You've got a current rear wing, and then the concept for 2026. Both the front and rear wings are going to have movable parts. This is no longer just a simple on-off button for overtaking. It's a fully active aerodynamic system that the driver will be controlling. So, drivers will be able to switch between two modes. You'll have a high downforce setting for maximum grip through the corners, and then a new low drag setting for blazing speed on the straights. And here's the game changer. They can do this anywhere on the track, not just in those old DRS zones. And the goals for these new cars are pretty ambitious. They're aiming for a 30% reduction in total downforce. The thinking here is to make the cars smaller, lighter, and more agile, hopefully putting more of the performance back in the driver's hands. But this next number is even more mind-blowing. A targeted 55% reduction in drag. That is a massive leap in efficiency, which also helps with the new sustainable power units. It means the cars are going to be incredibly slippery in a straight line, which could lead to some seriously high top speeds. Which brings us to the final, really exciting question. Imagine the strategy involved. When does a driver decide to go into low drag mode? Do you use it to attack or to defend? How will two drivers battle it out when they can both shed drag whenever they want? The 2026 rules aren't just a small step. They could completely rewrite the playbook on how you race a Formula One car.